Okay, let's start the next part today, and this is the last part of organic chemistry, elimination reaction. And next day we'll start next subject, so next topic, polymer. Let me see how much we can complete today. Okay, so the reaction is elimination reaction. Different type of reaction we are studying: substitution, addition, and now elimination. Elimination reaction, as example. Oh, just a minute. Elimination reaction is removal of some small molecule and double bonded compounds are formed. That is elimination reaction. Okay, we are having some molecule like alkyl halide and we are giving some alkali like NaOH or KOH. Then it is removal of some group like HCl or HBr. That groups goes out, giving us a alkene compound. That is called elimination reaction. Here, example: CH3, CH2, CH2X. This is called propane corresponding alkyl halide. So it is propyl chloride or propyl bromide, propyl iodide type of compound. Now we are giving some other, propyl halide, chloride, bromide or iodide, so halide. Now we are giving some sort of activating agent like OH minus that will remove this H and X from here, producing a double bonded compound. Now it is found always elimination and substitution occurs together. Whenever we try to do substitution, some amount of elimination will be there. And if we try to do elimination, some substitution will be there because the reagent is same. Number one. Number two, the intermediate is common. If we go by SN1 reaction, E1 mechanism is also there along with it. What is E1 reaction? It is also elimination via carbocation mechanism. First of all, carbocation formation. After the formation of carbocation, there are two options open. Either it will give substitution product, that is alcohol, or it will give the elimination product, that is alkene. These two things will be always together. So SN1 always accompanied by E1 and E1 accompanied by SN1. Now depends that what we will prefer, elimination we will prefer, and what we can do. We are just changing the concentration of the reagent. If we take dilute NaOH, then substitution will be measured, and if we give concentrate NaOH, then elimination will be measured. Why? I think this we write down. You cannot remember. You will forget. And these are the point where we will make questions. Obviously, this is a very important point where we will make questions. Okay. SN1 versus E1. Okay. Yes, that's also maybe. So SN1 versus E1 mechanism. So first you write down, there is a common carbocation intermediate for SN1 as well as E1 reaction. There is a common carbocation intermediate for SN1 as well as E1 reaction. If we apply concentrate NaOH, if we apply concentrate NaOH, elimination, that is E1, is preferred, whereas concentrate NaOH if applied, if we apply concentrate NaOH, then elimination reaction will be preferred, that is E1, elimination reaction, that is E1 will be preferred, whereas dilute NaOH will promote substitution, that is SN1, will promote substitution, that is SN1. SN1 means substitution and E1 means elimination. But why 1? Because unimolecular. So E1 elimination, unimolecular. SN1 substitution, unimolecular. Both are unimolecular, But in one case you are calling it elimination, other one you are calling substitution. But which one will be prominent? Depending on what reagent you are using. If you are using concentrated NaOH, then elimination is preferred. It is major. And if you use dilute NaOH, then substitution is major. Now you have to answer the reason why it is happening. This all statement is already given. Now you have to need explanation that why it is happening. Okay. And the explanation is this. First you listen and then we will write down. Okay. Let's get some idea. Otherwise you will not understand. See, whenever you are giving concentrated NaOH, means NaOH is having lot of OH minus, free OH minus, not surrounded by solvent. Whereas if you take dilute NaOH, then OH minus is always along with lot of H2 molecules. OH minus is there, but along with OH minus, you can you are providing lot of water molecules. Naturally, because you are giving dilute. So for dilute, we have two types of nucleophile. One is OH minus, other one is H2. Both are acting as nucleophile. So you are getting large number of nucleophiles. So obviously substitution will be prominent. Whereas if you give concentrated NaOH, then OH minus is free NaOH. OH minus is free OH minus, which is not surrounded by water molecule, and water molecule there is not acting much role. So what role is taken by OH minus only? It is abstracting proton because it is acting as a base. It is acting as a base, not as a nucleophile now. And so it is abstracting proton, giving you double bonded compound, alkene. Could you understand or not? Okay, let me dictate, write it down and read it once again, because sometimes you cannot follow all the sentences. Write down, then read it. Okay, I mean just dictate it. After that you try to read it out and understand. Dilute NaOH has a lot of water molecules, and both OH minus as well as H2O, both OH minus as well as H2O acting as nucleophile. OH minus as well as H2O acting as nucleophile. So substitution is preferred. Both are nucleophiles, so substitution is preferred. Too much of nucleophile you are getting, so substitution is preferred. Okay. Large number of nucleophile you are giving. OH minus as well as H2. Large number of nucleophile. All are doing substitution. So substitution, only substitution. So that is becoming major. On the other hand, concentrated NaOH has, on the other hand, concentrated NaOH has OH minus as free basic species, base acting as a base. Okay. Base species. OH minus is base species. That is a base. Abstracting proton from the molecule. It is acting as a proton abstractor, abstracting a proton from the molecule, giving elimination. Okay. So could you follow? Not now. Just think.
Abstracting
proton from the molecule, giving elimination product. That is alkene. Giving elimination product. That is alkene. Now look at here. At the board, this OH minus acting as a base. Suppose this OH minus acting as a base, then what will happen? It will give elimination. This OH minus acting as a nucleophile, then what do you get? Substitution. But OH minus surrounded by water, they are also acting as nucleophile. So we are getting large number of nucleophiles. OH minus and H2O both are nucleophile. You are getting large number of nucleophile. So concentration also matters. You have a large number of nucleophile. So that's why substitution is prominent. On the other hand, if you have the concentrated NaOH, then OH minus is free OH minus, which is acting as a base. Two types of NaOH, OH minus free and OH minus surrounded by water. I'm just telling these two differences. If OH minus is free, it is abstracting proton. It is proton absorber, abstractor. It is abstracting proton giving alkene. And if the OH minus is surrounded by water, both OH minus as well as H2O acting as nucleophile. So substitution is major. Now understood? I told just you write down, then you understand. Acha, next, another thing. Here, if you have polarity, higher polarity of the solvent. So in this case, you need to mention that if you have a higher polarity of the solvent, then only this SN1, E1, this type of reaction can occur. Highly polar solvent only can facilitate this type of reaction, SN1, E1, because carbocation intermediate is forming. And carbocation intermediate can be formed only when you have a polar solvent. Okay, so solvent is polar solvent in this case. SN1 both E1 as well as SN1. Okay, but only variation is what? Variation is your base. Whether you are using a dilute base or a concentrate base. If you are using dilute base, substitution will be measured. And if you are using concentrate base, then elimination will be measured. That is very much clear. Now another thing. If you have a bulky molecule like tertiary butyl chloride, bulky molecule, it has a natural tendency to undergo elimination rather than substitution. Why? Because it is already sterically crowded. So it will release, the first steric crowding is released when carbocation is formed. Now after that, if it undergoes substitution, again steric crowding is reintroduced. Specific term. It is called steric crowding is getting reintroduced. Whereas if it undergoes elimination, it is sp2 carbon will be sp2 only. That is the benefit. Because sp2 means 120 degree bond angle. Distance is more. So steric crowding will be less. So once the steric crowding is released, molecule will not try to go towards steric crowding once again. Rather it will prefer what? Elimination. So that sp2 carbon will be sp2 carbon only. Bond angle will be 120 instead of 109 degree, 28 minutes. So it is better because molecule was bulky. So the bulk is removed. So steric crowding reintroduced is not a favored condition. So molecule itself will prefer elimination. That is another factor. One factor, solvent factor, that I already have discussed earlier. Now this factor is called release of steric crowding phenomenon. Molecule is already sterically crowded, so it is very much uneffective. Very much uneffective. Now you are creating a situation so that it can release the steric crowding. And after that, the steric crowding is reintroduced as not a favored condition. It will itself prefer elimination rather than substitution. Okay. So a little bit of complication now. If I have polar solvent, then I told that polar solvent and dilute solution. Then substitution is preferred. But here you get 60-40 product. Elimination 40%, 60% substitution. That is also major minor, 60-40. But if you give concentrated NaOH, then elimination is preferred. But here it is 80-20. Because molecule had its own urge. Molecule has got its own urge. Okay, its own tendency. That is getting added up. Is it very complicated you are thinking? No. Okay, na? Understood? Fine. So these two factors. One is the solvent factor. Another factor is already remaining inside the molecule. Molecule want to undergo elimination. You are helping it to go to the elimination.
Some reason or what?
Reason is steric crowding, release of steric crowding. That is the reason. It will prefer elimination. Why prefer elimination? Yes, bulky molecule, these different groups are one above another. There is sort of interaction called dihedral interaction. That is making overall molecule unstable. This dihedral interaction also makes the molecule unstable. So if you allow it to release the crowding, molecule will prefer always that. So molecule is own tendency and the solvent factor, both are going in same direction. So it will give you 80-20 product. 80% elimination, 20% substitution only. Whereas if you give the condition so that substitution will be prominent, so in that case it will be 60-40. Major minor, fine, but only one factor, no? Other factor is the opposite direction. That's why you get only 60-40 product. There also you are calling in major minor. But 60-40, 80-20, for your understanding I told you. That I cannot tell you. It will depend on the molecule. But why you are telling 60-40, 80-20? To make you understand that actually two factors there. Sometimes one factor is there. Okay, if the one factor is prominent, then you are getting some product. And if both the factor is going in the same direction, the this product major and minor, the major minor factor is becoming much more prominent. Okay. Anyway, so this is elimination. Let's go ahead. So here is a base, removing HB here and making a double bonded compound. That is elimination. Now, if the double bond is occurring at the nearby carbon, it's called alpha elimination. If it is in the next carbon, it's called beta elimination. And next 1,3 elimination is called gamma elimination, and so on. Okay, alpha elimination means 1,1 elimination. So 1,1 elimination, for example, you have both the halogen in the same carbon. Okay, and your double bond is forming, or triple bond is forming. Double bond as well as triple bond both can form. So elimination means it can give you double bond, it can give you triple bond. Normally you are getting double bond and triple bond, alkene and alkyne. So suppose you have a carbon bearing 2 chlorine atom, CH3, CH, Cl2. In that case, you are getting elimination. So here, both the halogen will be removed from the same carbon. So alpha elimination. And sometimes you are getting, you have XX or a halogen in 2 adjacent carbon. And you are removing that halogen, chlorine, you are giving zinc dust and heat. Remember, long back you have studied these things. CH2Cl, CH2Cl. You are giving zinc dust and heat. Getting CH2 double bond CH2. So this type of compound. So this reaction is called 1,2 elimination. Isn't it? It is 1,2 because it is removing from both the carbon. Both are halogen getting removed from the same carbon, but 2 different carbon. 2 different carbon. Okay, this is a one type of elimination. Or otherwise in the same carbon you have both the halogen and getting removed. So that is also possible. So these way you are getting different type of elimination. Alpha elimination, beta elimination, gamma elimination. So this one is one X and H both are getting removed. So it is 1,2 elimination. So this is the E1 mechanism. First carbocation is formed, followed by release of a small molecule. First carbocation is formed, after that release of a small molecule. How? Suppose Cl goes out first, forming a carbocation, and after that H is going out as H plus. But it will not go by itself. That's why you have to give some catalyst, that is alkali. That alkali catalyst will remove that H plus, producing in fact H2O. Practically the H2O, but maybe it in different form, means X minus first, followed by your OH minus and H plus, making it H2O. That we are actually showing, but removal of what? HX, HCl, HBr, that is getting removed. So this is elimination, and this is the mechanism. In this case, it is happening in 2 steps. This is the RDS, carbocation formation. That is always difficult because it is endothermic process. After that, the B minus means base. Suppose OH minus is abstracting a proton from here, this carbon, next carbon, so that the double bond can be formed, and we are getting a double bonded compound. So here also you can see that H2 is abstracting the H, giving H3O plus, and OH minus is going out as a H2. Here it is removed. It is some group is there like OH group. So this OH group is becoming H2O plus and then going out as a H2O molecule. So this is the mechanism E1. 3 degree will be always preferred compared to 2 degree, which is much more preferred compared to 1 degree, because this is 3 degree carbocation, this is forming 2 degree carbocation, this is forming 1 degree carbocation. So 1 degree carbocation is less stable, and 3 degree carbocation is the most stable, least stable, most stable, and 2 degree is medium. So 80%. By the way, here there is a rule called Sedgwick elimination rule. Sedgwick elimination rule. Name of a scientist. Sedgwick is a scientist, just like we say Markovnikov addition. So Markovnikov scientist. So here Sedgwick is a scientist. So according to this Sedgwick rule, if you have 2 options, the double bond can be formed here or here. Double bond in the middle is preferred compared to in the terminal, because if it is made in the middle, then this compound is more stable. Why more stable? Okay, why more stable? Because this molecule is having hyperconjugation. Hyperconjugation. Okay. So how many hyperconjugative hydrogen in this case? With respect to this double bond? 6. So this is giving 6, whereas here you are getting only 2. No, 2. These two. Others are not acceptable. Only these two. So here we are getting 2 hyperconjugative hydrogen, and here we are getting 6 hyperconjugative hydrogen. So that is most stable, and most stable will be preferred according to thermodynamics law rule. So it is called thermodynamically controlled product. Already I told you a few times thermodynamically controlled product and kinetically controlled product. So where thermodynamic rules, that is thermodynamically controlled product. Here thermodynamics rules, because thermodynamics is telling more stable products should be formed. Okay, and according to this del G, del H, this concept, del H concept, exothermicity, all. So if you follow that, this product is supposed to be formed, and it is forming more, 80% we are getting. So when it is following this thermodynamic rule, it is ZJ product. Sometimes we are getting this type of product more, not in this condition, some other condition. We are getting this. In that case, we call it Hofmann rule. Hofmann rule. That also happens. But here, if this is the condition, means you are giving NaOH, aqueous, NaOH, medium, etc., then it will be giving you ZJ product. Means 80% ZJ product and only 20% Hofmann product. This we can call Hofmann product, which is terminal double bond. We are calling it Hofmann product. And when you are getting double bond in the middle, which is giving more stable product, it is called ZJ product. So ZJ product, what is the spelling of ZJ? SAYT-JDFF. ZJ. SAYT-JDFF. ZJ product. You can write down ZJ product. So this product is called ZJ product, which is giving more stable 80% of this out of this elimination. Other one is called Hofmann product, what we are getting only 20%. Here in this case, but in some other condition, that Hofmann product also may be prominent. Why or when? If you have a very bulky structure, very bulky structure, and your base is also not in NaOH, which is also a bulky base. You are using a bulky base, all the molecule is bulky. In that case, molecule will prefer elimination at the terminal. Why? Because the base cannot penetrate further. Okay, if there is no space, base cannot enter there. So in that case, this Hofmann product can be prominent. That's the exception I am telling. Yes, ZJ rule. SAYT-JDFF. I told you, ZJ rule. So actually other language. Okay, so this is the compound. Here is the iodine. So this iodine must be removed, and one A. There are two beta positions. One is here is this carbon is beta 1. These two positions are equivalent. That's why beta 1, and this position is beta 2. Different position. That's why beta 2. What the difference? Beta 1, beta 2. Beta 1 is the position where from hydrogen can be removed. Beta 2 is also another position, another option where from hydrogen can be removed. So accordingly we are getting two different products. Major product is A and minor product is B. Why? Again the same thing. If you make a double bond here, how many you are getting? Alpha hydrogen you are getting? 2 here, 4. Alpha carbon is this and this. So you are getting 4 alpha hydrogen. But if you consider this one, how many alpha hydrogen you are getting with respect to the double bond? This is 1 alpha carbon, this is 1 alpha carbon, this is 1 alpha. 3 alpha carbon. And how many alpha hydrogen?
7.
Yes, 7 alpha hydrogen. So obviously this is preferred. So this particular product is found to be obtained. We are getting more this product. More we are getting this, and minor product is this. Okay. Actually, in English we are calling it Zaitsev. Some other maybe Latin it is Zaitsev. Alexander M. Zaitsev. So alpha carbon, beta carbon. Another example you just check. This is alpha. What is the alkene? First you find out where is the halogen. This is the halogen, bromine. With respect to this brominated carbon, this is the carbon. So this is alpha position with respect to the bromine. Then this is one beta, this is one beta, this is one beta. Okay. So this particular product is found more. The double bond will be found here. This double bond also could happen, but it's not happening much. This is major, minor. This is major, and minor will be here. Exo double bond. Double bond with respect to the ring, if it is flanked outward, outside the ring, it is called exo double bond. Outside, na? Exo double bond. This exo double bond is less stable compared to this double bond in the ring, annular double bond. This is called annular double bond. There are names for everything. This is called annular double bond, and when it is going outward, the double bond is forming double bond CH2 like that. Outside the ring, it's called exo double bond. So exo double bond is less stable compared to annular double bond. Is the language clear? Earlier also it was there. Annular double bond, exo double bond. This is annular double bond and this is exo double bond. So annular is more stable compared to exo. Okay. Why? Because of this alpha hydrogen, that concept only. Another thing is also there. If the double bond is there, exo double bond is there, it is giving the ring more stress. That is another factor. The molecule is more stressed. Okay. Double bond compound, just tell me, what should be the bond angle of an hexagon or pentagon? 120 bond angle?
Ideal pentagon.
No, hexagon? Pentagon না, hexagon. Hexagon এ bond angle কত হবে দেখো তো? কত হচ্ছে? 60 হবে তো? 60 হওয়া উচিত তো? But actually when you have double bond, what is the bond angle supposed to be? Double bond হলে কত হওয়া উচিত? 120. sp2 have it is, no? 120. But you are forcefully making it 60 because that is a restriction. Hexagon, na? You cannot make it 120. 60 is supposed to be, but double bond is there, so 120. The whole molecule will be twisted. It will not be planar anymore. Supposed to be 120, but you are making it 60. How the molecule can attain the situation? How it can handle the situation? Got the idea? So in that case, what will happen? The molecule will be twisted, not a planar one. Normally you are writing like this, no? That will not happen because it will be under stress. Now coming to E2 reaction. Elimination bimolecular.
So
Annular double bond and exo double bond. Annular means inside the ring, exo means outside. Okay. Now E2 reaction. What is the meaning? E2 means bimolecular. Bimolecular elimination happens whenever, just like this. See, something is coming which is provoking the reaction. It is a provocation. Provocation, you understand, na?
yes.
So yes, so this is giving the provocation. This coming and pulling it away, and another double bond is formed in between because both are pulled away, torn apart. These two things are torn apart, so automatically double bond will be formed. So and the whole thing is happening together, simultaneous. That is A2 elimination. Requires a strong base for E2 elimination. Yes, another, this one. This is the alkyl halide. Now if the base is coming, which is a very strong base, it will abstract the proton, that will help to remove the proton, and at the same time simultaneously X also will go out. So this H is taken by the base and the X also must go out so that a stable compound can be formed. And if it happens like that, then you have to cross certain barrier. This is the barrier. It is called transition state. Always same type of diagram we will find. One transition state, one reactant, one product, and if it is a bimolecular, you will not find any intermediate. So this is a single step simultaneous process, E2. Single step simultaneous process. That is E2. And E1, there will be two steps. In between there is intermediate. Carbocation intermediate, which is common for both SN1 and E1. There is always competition between the SN1 and E1. Which one will happen? Now, depending on the molecule, sometimes E1 can be some amount more. Sometimes SN1 can be more. Depending on the bulkiness of the molecule, how much bulky it is. If it is more bulky, it will prefer elimination, so you get more product. Elimination. রিয়াকশনে পড়ে না, আর বাড়তেই পারে, কে বলেছে সবসময় কমতে হবে, কখনো বেড়ে যায়, বলেছি না কাইনেটিক্যালি কন্ট্রোল প্রোডাক্ট হতেই পারে। There is no hard and fast rule that product will be more stable than the reactant. There is no rule like that. Usually it happens, maybe 80% cases, but other cases also there where product stability is less than the reactant. It happens.
Why the reaction will happen?
Why it will happen? Because it has already crossed the hill and coming back through the hill is becoming difficult. पहाड़ चढ़ के उस तरफ गया, वापस आना मुश्किल पड़ रहा है क्योंकि एनर्जी नहीं मिल रहा है, तो उधर ही रह गया, चला गया तुम उधर, नौकरी लेके चला गया, बैठ गया, वापस आना मुश्किल पड़ रहा है क्योंकि दूसरी इधर का नौकरी तुम छोड़ के गया था, है कि नहीं? होता है ना? हाँ, तो लाइफ में वैसे होता है और इधर नहीं होता। अच्छा देखो, बेस इधर से H प्लस को एब्स्ट्रैक्ट कर रहा है, बेस इज यूजुअली माइनस, दैट्स व्हाई माइनस डाल दिए। Okay, this is abstracting this hydrogen and it is removing this X together, and this is only one transition state and there is no intermediate, and directly we are getting the product. So this is E2. This is most stable product, this is least stable product, and usually most stable product is formed more. Usually most stable product is formed more. Sometimes making that most stable product is very difficult. So the barrier is very high. So molecule could not cross it. So in that case, it is going for a easier way. Okay. Say I am giving a good example. Suddenly I remember. If you study hard, you will do better in your life. But always you are studying. So you will become more stable product. Are you becoming that? तुम लोग कर रहे हो? नहीं कर रहे हो। क्यों? जो easier तुम वो अपना रहे हो. Because just watching the mobile, it is easier. So you are doing. हाँ, अच्छा मेरा एग्जाम्पल है ना, रियल एग्जाम्पल है, एक्चुअली हैपनिंग. यू नो वेरी वेल दैट इफ यू ट्राई हार्ड यू विल बिकम बेटर इन लाइफ. तुम लोग जानते हो, करते हो क्या?
नहीं सर.
तो इससे अच्छा एग्जाम्पल क्या हो? तो मॉलिक्यूल इज ऑल्सो लाइक दैट. Molecule is also like that. If it can go there, it is better, but it's not getting energy there. You are also not getting energy to study, so they are also not getting energy to go there. If it gets energy, then it will go. And if it goes there, it will be more happy. If you are settled in life, you will be happy. But are you studying? Acha, I told you now there is another product called Hoffman elimination product. Just see, this is the example. Hoffman elimination means the Sedgwick rule is here not followed. Sedgwick rule is not being followed, and your more stable product is not happening. And why? Let's understand that. This NCH3 whole thrice plus, NCH3 whole thrice plus. This is the outgoing group, leaving group. This is the leaving group. Now this group is so large. Okay, this, and if it can go out, it will give a very stable compound, that is trimethylamine. So this is called trimethylium cation. So this trimethylium is attached to the molecule. If it can go out, it will give a stable product. NCH3 whole 3. NCH3 whole 3. Trimethylamine. Good stable product. So that is the tendency that it will go out with the help of Ag2O as a base. But Ag2O, is it a base? You know it's oxide. But in aqueous medium, Ag2O can form AgOH temporarily. It's not a very stable product. If you take AgOH and keep it, it will become Ag2O. But in suspended condition, AgOH can be formed. AgOH. But AgOH you cannot keep in a bottle. It will become Ag2O. Okay. So this Ag2O, that's why it is written, see, Ag2O heat. It is acting as a base here. Cu2, copper oxide. Copper oxide. Is it a base? Not so much. But copper hydroxide supposed to be a base. So this type of compound, it is in between oxide and hydroxide sometimes. Some amount of hydroxide, some amount of oxide can coexist together. Okay. So here this Ag2O and heat, it is giving this elimination, but the Sedgwick product is minor and Hoffman product is major. Why? Because this AgOH, which is acting as a base here, is a big one. Silver is a big molecule. So it is a big one compared to Na, sodium. This is a big one. And so in case of sodium hydroxide, Na plus is not coming in picture, only OH minus. But in case of AgOH, it's not happening. Ag plus OH minus, do you expect? No. Why? Because Ag plus OH minus, that polarity is not that much like NaOH. Na plus and OH minus separated already. But AgOH, is it separated that way? Ag plus plus OH minus? No. It is a molecule, AgOH. AgOH is a molecule, not 100% separated. Maybe a few molecules separated. Maybe some molecules of Ag plus and OH minus. Not as a whole. But NaOH, Na plus OH minus, separated, 100%. Okay, that's the difference. So here AgOH is a big one. It cannot penetrate much inside the molecule. It will prefer the terminal double bond because this is less crowded. जहाँ क्राउड है उधर नहीं घुसेगा. बड़ा सा गाड़ी लेके छोटा सा रास्ते में नहीं जा सकते. तो क्या करेंगे? हाई रोड से जाएंगे. हाईवे तो साइड में खड़ा रहेंगे, देखेंगे साइड से जहाँ मिलता है वहीं से ले लेंगे, अंदर नहीं जाएंगे. अंदर जाके तो फंसेंगे, तो ये नहीं जाएंगे. एकदम रियल लाइफ एग्जाम्पल यही होता है. रियल लाइफ ये तुम भूलोगे नहीं. ऐसा ही बुक इस किताबें बातें बोलेंगे तो भूल जाओगे. तो ये सब याद रहेगा. देखो रास्ते से गाड़ी जा रहा है, बड़ा सा गाड़ी, तो तुम्हारा अंदर का छोटा छोटा रास्ते में नहीं जा पाएगा ना, फंस जाएगा अंदर. तो क्या करेगा वो? हाई रोड के आसपास में जो मिलेगा वही कोशिश करेगा लेने का. सो ही इज ऑल्सो डूइंग लाइक दैट. इज ऑल्सो डूइंग लाइक दैट. वो अंदर जानने के उसके लिए मुश्किल होगा, तो साइड से वो डबल बॉन्ड जो रिएक्शन हो सकता है कर लिया. सो यू आर गेटिंग मेजर हॉफमैन प्रोडक्ट बिकॉज दिस पर्टिकुलर ग्रुप इज क्वाइट बल्की एंड दिस AgOH is also big. It cannot penetrate here. Penetrating here will be difficult for it. देखो there is methyl, another methyl, so many methyls. It will be difficult for it. So it will prefer removing H from here. So this is the elimination by Hoffman's rule. If the another thing, if Y is B, here is a Y. Just see, this is the leaving group. This Y is the leaving group. Now this is supposed to be going out. Now there are options. Option 1, option 2. Double bond can be formed this side, double bond can be formed this side. Now if you increase the bulk of this Y, धीरे धीरे Y को बड़ा कर रहे हो. In one case bromine, the SME2 plus, NME3 plus, बड़ा कर रहे हो उसको. ब्रोमीन को ब्रोमीन छोटा, SME2 plus उससे बड़ा, क्योंकि S के साथ दो Me ऐसा करके फैला हुआ है. ओके, इट इज फ्लैंक्ड, तो बड़ा हो गया. और Me भी तो CH3, HHH, तो कितना फैल गया. हाँ, तो बड़ा हो गया. और ये इसमें तो 3 मिथाइल है, CH3, 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 कितना बल्कि. So this much of bulky molecule if you give, then in that case your elimination 95% will be this terminal double bond. Last one you see 95%. Only Sedgwick product you are getting only 5%. But is bulky, less bulky comparatively. So you are getting 26% and 74%. And these are the actual data. That is the advantage of PowerPoint. I cannot remember this data and tell you. Okay. Data not possible. So here 90, if you take bromine, then 81% you are getting Sedgwick product, 19% Hoffman product. That means Sedgwick elimination is major. That is supposed to be. So always it is not 100%. There is no guarantee that more stable product will be always formed. No. Just see, this is the proof. Why? Because this is easier to make. So molecule is finding going this way will be easier compared to that way. Maybe in the long run it will be beneficial, but it is not going that long run. So going for a shortcut and giving this.
सर वो अल्फा और बीटा एलिमिनेशन तो
Alpha means actually gamma. Gamma elimination actually it can happen forming cyclic ring compound. Sure. 1, 2, 3 carbon. You have a chlorine here. You have making a cyclic chain, cyclopropane chain, cyclopropane. 3 carbon का ring. Yes. Triangle बन गया triangle. समझ गए? So it happens. अच्छा E1, E2. This is the comparison. Acha, last of all, this is the last thing because time is running out. So it is called E1CV. One example I can give, I think better example I can give. So E1CV, one example is here, but unimolecular elimination via conjugate base mechanism. Unimolecular elimination via conjugate base mechanism. It is called E1CV. What is that? I am taking a small example. It will be easier for you to remember. Benzene ring, কিছু না জলে বোতল আচ্ছা বেঞ্জিন ring, one lithium is attached. Possible. What is that compound will be called? Lithium? No. Phenyl lithium. Phenyl. এটাকে হ্যাঁ বেনজিন বলা যাবে না one hydrogen is removed from benzene it becomes phenyl. So phenyl ring attached to phenyl lithium, it is a very strong base. It is so strong that even before the removal of the formation of the carbocation, it is abstracting the proton. I am giving you the example. You will understand. This is the base. This is the base, and you have some alkyl halide. This is the compound. Now what is happening? This phenyl lithium is so strong a base. Why it is so strong base? Why it is so strong base? That is because if it can get one proton from somewhere, this becomes benzene. That is the driving force, making a very stable molecule. So it is very unstable and trying to get some proton from somewhere so that it can become benzene. That is its natural tendency. So it will extract this proton from here and it will give you carbanion, which is unlikely. Normally it is unlikely, isn't it? You get a carbanion because it has so much of urge. Forcefully it is, yes. Itself it will become stable, becoming benzene, and that's why it is extracting that bond here forcefully. Beforehand even the X is removed. X is not removed. So this is called conjugate base of alkyl halide. Conjugate base of the alkyl halide. What is conjugate base? Removal of one H plus from some molecule giving you the conjugate base. So it will come out like this and this will go out like this. You get the double bond. Got it? So this is I think the simplest example of E1CV mechanism. This is also E1CV mechanism. Here also there, but this I told you because it will be easier for you to remember. Benzene ring, just lithium, benzene is going out as benzene. And then you are getting a double bond. But the mechanism is different way. Carbanion mechanism. E1 is carbocation mechanism. Here it is carbanion. How it is formed? Because it is not giving enough time for the X to go out. Rather it is abstracting proton first. Then after that only X is going. So it is called E1CV mechanism. Elimination unimolecular but via conjugate base mechanism. CB is conjugate base. That's all.